All right, we're going to officially get started. It is the beginning of week 2, so it's Monday in business math, business 1353. It's 5/15/23. I appreciate everyone for showing up. We have, I think, everybody except for one, which is awesome, 8 out of 9 people. I'm going to share my screen, so hopefully everyone can see that. And then, of course, when I share my screen, everything goes wonky, so I have to rearrange. Okay, he said, I see your answer, but the book made me think I need 2 sets of 3. Okay. Did anybody else have a problem? Denominator? It's because you can find a common denominator pretty easily, but find the least common denominator, that's a little bit of a process. It's not so bad. It's just one of those things you have to practice at doing. We'll look at this in the problem. Find a prime number that divides evenly into any of the denominators. So remember, we're only dealing with prime numbers. Okay. That's what we're concerned with. Anybody have any questions on prime numbers? Everybody know what a prime number is? It's okay to say no, but we can cover it real quick. Kelly, I saw you kind of had a look. No? Okay. Okay, just remember prime numbers can only be divided by themselves in 1. That's it. So to be 1, 2, 3, 5, 7, 11. I never have memorized. 13, 17. All right. So those are your prime numbers. They can only be divided by themselves in 1 evenly. I should use the word evenly. So just remember what a prime number is. Now, let's look at the one he had a question on. There we go. Number 7 here, it says the least common denominator for the group of fractions. All right. First thing it said, write your denominators in a row. So we have 12, 14, 5, and 10. And it's easier just to start with the lowest prime number, which is going to be 2, and divide what can go into each one of these evenly. So 2 can go into 12 evenly, becomes 6. 2 can go into 14, becomes 7. 2 goes into 5, does not go into 5 evenly, so we bring the 5 down. 2 goes into 10 evenly, becomes 5. We look across here again. Okay, we can divide 6 by 2 again. So we're going to stay with 2. So 2 divided by 6 is 3. 7, 5, and 5, they can't do anything with them, so we drop those on down. The next prime number is 3. Right. 6. Okay, I'm sorry, 3. 3 will go into 3 one time. It won't go into 7 evenly, won't go into 5, won't go into 5. So we're done with the 3s. Once you get down here to 1, okay, you're done with that column. Now 5 will go into the 5s evenly. So 5 will not go into 1, 5 will not go into 7, 5 will go into 5, 5 will go into 5. Okay, so it's 1, 1, and 1. We drop our 7 down. And we do it one more time. We can use 7. 7 can't go into 1, but 7 will go into 1, 7 one time. Now, once we get all these 1s in a row, just like we did here, we multiply all these prime numbers together to get our least common denominator. So it becomes 2 times 2 times 3 times 5 times 7. And then they get 20 on this one for our least common denominator. Now, I see Kalia said, I went on YouTube for everything. That's fair. Math with Mr. J on YouTube is very helpful. I always tell people, and not as an insult, but just as a fact of, make life easier, go back to some of these guys who are teaching the junior high stuff, because they break it down really easy for you. And I may go too fast, or I just may not do it the way you like it. So that's your least common denominator. Otherwise, you can find any common denominator on any set of fractions here. You can find a common denominator, not the least one, by multiplying all of them together. 12 times 14 times 5 times 10. And that'll give you a common denominator. It'll give you a number that goes into all of them. But wrong button. There it is. But if you go to a calculator, 12 times 14 times 5 times 10, that becomes 8,400. And that's just a really, really large, crappy number to have to deal with. You can get to where you need to on any of your fractions from here, but there's no reason to when you can go ahead and get the smallest, what they mean by the least common denominator, the smallest one, by using this method here. Okay, and that'll make your life a whole lot easier. Keep reducing everything down to a minimum. Okay, any other specific problem on the you have a problem with? Adding, subtracting, all of it? Really? This is what we're doing, Kelly? We will cover fractions this whole time if that's what we need to do. I have no problem with that. Now, I might talk a little trash on the end in between, but that's just me. I want to look at something here then. Oh, you did fine. I went and looked at the grade book real quick. You did fine, Kelly. You're don't be so dramatic. All of it. Oh, you did well. So nobody has any more questions on these fractions, because we will move on. If you've got any, just speak up. That's why we're here. Going once, going twice. Sold. All right. Well, on this week's here, we have the next thing is checking accounts. I'm not going to cover that, guys. Okay, that is really easy. If you need me to help with it later, that's one down the road. Here is the one that's going to cause you some issues, and this is using equations to solve problems. And I'll just pull up chapter 5 right here. And we can look at, now these numbers may or may not be the same numbers as you have, and I'm fine with that. Okay, you're here, we get the extra help. Now, people, I've heard this, through this class a million times, which is, why do we put letters in with numbers, and what does that have to do with math? They're not numbers, they're letters. Well, yes and no. Andrew said, going back to the due dates, all my due dates say this for time, 9:59 p.m. GMT 6. Can you take a screenshot and email that to me, Andrew? Because I will show you real quick. I have all the dates set up right here. And all of them are 11, he did it Eastern time, or 11:15 Eastern time. And the reason I haven't changed it up till now is because I've tried that before, and it becomes, oh, Whitney's here. Whitney, don't leave without hollering at, don't leave class without hollering at me later, please, and thank you. So I will make, like, where are we at here? Okay. Let's look and see what he says about it. Okay, that's mountain time. Where are you located in Oklahoma? Or where are you at, Andrew? Just as curiosity. You're in Tulsa. I don't know why it's showing mountain time. That is real weird for you. That should still be the same time as we're showing here. But let me look. We're on chapter 4 next. So what's going to happen is instead of it being do the 17th, I'm going to make it do the 18th at 12:59 a.m. So don't let that throw you off, because what happens, that hour is going to throw it to the next date. I can't change this. I'm pointing to it like you can see it. I can't see my finger here. I can't change this part because once that is set up, it's in stone. It's one of the few things they don't let you change. So we'll just have to do a workaround. And so I will change that. That'll be changed tomorrow. So you don't have to worry about running out of time again, hopefully. Because 12:59 on the 18th should be 11:59 on the 17th. Okay, so we were getting back to letters and numbers. Okay. Remember that those letters are called variables. They are numbers. They are 100% numbers. They follow the same rules as numbers. They act like numbers. The difference is we use those letters to represent an unknown number. We don't know what the number is. We have to put something in its place. We could put, we could put a squiggly line. We could, use anything, but letters are the next obvious choice. So just remember those letters are variables, they're unknown numbers. Your job is to find that number. Okay, find out what, in this one, D is equal to. And your entire process, everything you do is to get D. Now I'm going to refer to one side of the equation and the other. The way that's split up is at the equal sign. So if I talk about the left side of the equation, it's going to be left side of the equal sign. If I talk about right side of the equation, it's going to be right side of the equal sign. Okay, because that is our balancing point. Because there's two things. Number one, you want to get D by itself on the left side of the equation. So you want it to say D is equal to something. All right. The other thing you want to do is you want to get D by itself on the left side of the equation, but you want to keep the equation balanced. Anybody remember the movie The Matrix? Anybody big Matrix fans in here? Okay. Remember I do. Remember Neo? Okay. Just as an aside, Andrew, do not watch the new one. It is hot garbage. It will ruin everything for you. I say that. Watch it. You may like it. It was pretty terrible though. Remember that the one Neo was the product of an unbalanced equation. And so we're not going to create an all-powerful being by not having balanced equations, but we will get the wrong answer. Now, you need to decide what they're doing in the equation, because what you want to do is move this number away from this D. You want to get it to the other side of the equation. Okay. Doing that, you have to look and see what they're doing here, which they're subtracting, and you have to do the exact opposite. And once again, remember, we're talking about the left side of the equation and the right side of an equation. So if they're subtracting 33, you must add 33 to this side of the equation. but you have to keep it balanced. You have to do the exact same thing over here. You have to add 33 to the other side of the equation. Okay. So whatever you do on the left side, you do on the right side. Whatever you do on the right side, you do on the left side. You do the exact same thing. You don't change. If you subtract on one side, you subtract on the other side the exact same number. Same thing with multiplication, division, all that. It has to be exact same. And my old algebra teacher, Mr. Osment, he was quite a character, and he would jump up and down and say, if you spit on one side, you spit on the other side. And he went as far as, if you flick a booger on one side, you flick a booger on the other side. We were children, we were in high school, we found that stuff amusing, and it stuck with me 35 years later. So all that being said, so let's look and see what they do here. D minus 33 is equal to 40. We're looking for the value of D. See how you want D by itself on one side of the equation? And they give you an explanation here. They're subtracting 33. So you add 33, because if you take 33 minus 33, you get with 0. So it just kind of disappears out of that side of the equation. You do the same thing here, add 33 here, because what we're dealing with here is subtraction. Is we can call it subtraction. We can also call it a negative number. All right. Negative numbers exist, and those are numbers that are less than 0. And we can go back and we can talk about our checking accounts, although we're not going to cover that in chapter 4 today. Okay. But all of us old enough to actually, write checks and keep a ledger. If you have $50 in the bank and you write a $100 check, that means you have negative $50 in the bank. It is a negative number. In order to come back up to 0, you have to put at least $50. You have to put $50 back in the bank, right? So if you have negative 50, or let's say negative $33 in the bank, I have to add $33 back in to bring it back up to 0, because what we're trying to do is trying to zero that out and get it out of the way of that D. So D is equal to 73 once you add these two together. Now, in order to make sure your answer is right, and this is a really simple one. I know I'm kind of beating up on this number 1, but it's a simple one. It kind of gives us a good example. Is you go back to the original equation right here. Remember, always go back to the original. Now, D is no longer unknown. We have a value for D. D is now, we have decided, 73. Okay. So wherever I see D in here, I put 73. And then I just see if it makes a true statement. And they do it here. 73, they replace D, minus 33 is equal to 40. 40 is indeed equal to 40. It's a true statement. That means we got the problem right. Easy peasy. Okay. Questions? I don't know what to do with my hands. I'm like Ricky Bobby. Covering really good. Yeah. So nobody. Shake and bake. The best terrible movie. The best terrible movie I've seen in a while. I watched Renfield last night with Nicolas Cage as Dracula. Spot on. Hey, we don't watch you shaking there, Kelly. We don't hate on Nicolas Cage. God among men. The greatest actor to ever live. The greatest bad actor to ever live. Okay, so does anybody remember me saying last week, let's look at number 2, that you do need to watch Renfield? It is pretty great. It's also the guy who played Beast in the X-Men movies plays Renfield, and Nicolas Cage plays Dracula. It's pretty terrible and gory and bloody, and I loved every second of it. So remember when I said last week that a fraction was just like a division problem, that you can also read that as z divided by 3, z over 3, z thirds, right? So that line there, there's actually a thing, I will find it on another page here while I'm talking to it. So just remember that a fraction is actually a division problem, among other things. And I actually read this. There was an explanation. Oh, I don't know where I read it. Okay, I'll have to find it later. But why they, oh, that's why. Here's the funny thing. If you remove these numbers and put a dot on top and dot on bottom, that's a division sign, right? The division sign is actually a representation of a fraction. And that dot on the top and bottom represents numbers. Does that make sense? So it's kind of the same thing. It's just weirdness. So this is z divided by 3. Now we need to remember that we said we need to do the opposite, right? The opposite of division is multiplication. So if they're dividing by 3, we need to multiply times 3. Because what happens is that these 3's, 3 divided by 3 becomes 1. And so you just end up with 1z. All right. But if I multiply this side by 3, I have to multiply this side times 3. So 3 times 35, it's 90, 105. Yep. Oh, I'm looking at it. 105. Okay. So multiply this 3, get z by itself. Multiply 35 by 3, 105. Okay. All right. Now we go to check it. I know what the problem. Sorry, Kelly, you got to remind me. You have to remind me, guys. I'm goofy. Oh, yeah, I'm goofy because I'm poor. If I was rich, I'd be eccentric. So we now, z is no longer unknown. Z has a value. We found it. We've decided z is equal to 105. So we go back to our original equation, and in place of z, we put 105. You'll see they do that here. And we can also read this as 105 divided by 3. So does 105 divided by 3 is equal to 35. 35 is indeed equal to 35. We have a true statement. We have our proof. We've proved it to be right. Okay. Anybody have any questions on that one? Because it's going to get a little more complicated. Just a little, not so bad. Okay, because what we're dealing here, and I sometimes forget to say it, we're dealing with linear equations here. And when I say linear, L-I-N-E-A-R, the first 4 letters of linear mean line. So these equations represent a straight line. If you were to graph them out on paper, if you were to draw this out as a physical representation of what we're looking at here, it would be a straight line of some. Now it may be this way, this way, this way, this way, this way, but it represents a straight line. And you're only dealing with one variable at a time. There are times you may have to deal with 1, 2, 3, 4, 5, 6, 7, 8, 10 variables. You know, you won't have to. Don't look panic, Kelly. You know, we did that in like linear algebra in college. You know, so because you would deal with the x-axis, the y-axis, the z-axis, okay, and then the 4th dimension, which is time, and then you would deal in 5, 6, 7, 8, 9, 10 dimensions, and that comes out into all this theoretical stuff, which, you know, has no use for us here. So just remember, We're just dealing with one different variable. Later on here in this stuff, you're going to deal with two variables at some point, but you're going to take that second variable and turn it into a version of the first variable. So in the end, you're still dealing with one variable. And that sounded complicated and weird, but you'll see when you get there. Okay, the equation here. Now, let's just look at this kind of on its own. R is our variable. Now, on this side of the equal sign, we have the 5, keeping it from by itself. We also have the 37, keeping it from by itself. So we have to move all those numbers to the other side of that equation, to the right side of the equal sign. Right. What I tell people is you go to the number farthest away from the variable and move them and get closer. All right, so you move in towards the variable. That's not, and that's because with math, there's always 1,000 ways to do it. I'm just trying to help you guys the easiest way, because there's many, many more ways to do it. So the thing farthest away from the R is 37. They're adding 37. So we're going to subtract 37 from this side, and we're going to subtract 37 from this side, which gives me, what's that, 31. All right. So we're going to be left with R over 5 is equal to 31. They're dividing by 5. We're going to multiply times 5. 31 times 5 is 155. Boom, right there. Okay. And then let's just look at it. Let's just look how they did it. So they subtracted 37 from each side, just like we said before. That turns out to be 0. So that just goes away. We do the same thing to the other side of the equation. And it doesn't matter. There could be another variable. There could be all sorts of garbage on the other side of the equation. It doesn't matter. You still do the same thing. You subtract that 37. So we have R over 5 is equal to 31. We multiply both sides by 5. These cancel each other out, leave us with just R. 31 times 5 is 155. So now R has a value. R is no longer unknown. It has a value. Now, here's the tricky part. Let me pull something up here. When you go to do these proofs, and it looks like this, there are some rules you need to know. And this rule here, okay, I don't know if anybody remembers this, PEMDAS, PEMDAS, okay? The way we had to remember that is, and I'll tell you what it means as we go along. Please excuse my dear Aunt Sally. When I taught high school, it was please excuse my dumb algebra student. And then I had one morbid girl, she was a freshman years and years back. It was please excuse my dead Aunt Sally. So however you need to remember it. Okay, P stands for parentheses. E stands for exponents. I don't know what word that is. I must got off. Exponents. There we go. Let me make this larger. Let's do this. Okay. M is multiplication. D is division. You see where I'm going with this? Addition and subtraction. All right. So This is what we call the order of operations. So when you're solving that thing with all those numbers in it, this is the order in which you must. You solve what's in the parentheses first. Then you do exponents. You do multiplication and division in the order in which they come. Addition and subtraction in the order in which they come. So, and the reason I'm bringing this up is when you go to replace this 155, that R, okay, you're going to do this division right here first. You're going to take 15 divided by 5, which is 31, then add it to the 37. You must do it in that order. Okay, if you try to do it in a different order, you're going to get all messed up and it's going to get ugly. But if we do that, 155 divided by 5 is 31. 31 plus 37 is 68. 68 is indeed equal to 68. We have a balanced equation. We know we did it right. All right. Anybody else? Any problems, issues, questions? I'm here for you. All right. Now, here's where we were talking about how it can get a little more complicated. We have a C. There's our equal sign. We have a C over here. We have a C over here. Two of them actually. We have negative 2 C's over there, right? Once again, we need all those C's over on one side of the equation. Now, depending on the equation, but for the most part, I'm going to say take this negative 2C, and I want to move that stuff over here. Kelly asked if our grades suck on the assignments. Well, the discussions, we sent it to everybody, so it's not like a personal message. If our grades suck on the assignments, will the discussions and class participation balance out pretty much? Yes, but I have butt face right now. Yes, but, which means everything I said before I said but was BS, right? You do have 5 opportunities for each assignment to go back and get them done. So you shouldn't suck that bad. You might suck it up a little, but you shouldn't suck it up that bad. If you go back and knock the top off these first 2 weeks the best you can, then that gives you a little leeway on the next 2 weeks if you mess up on an assignment or two. So the first thing I'm going to do is I'm going to take this and move it over here. Well, how do I do that? They're subtracting 2C. I'm going to add 2C. So I'm going to add 2C to here. I'm going to add 2C to here. 2C plus 1C is 3C, right? And we don't have to call them C's. We can call them oranges. We can call them, you know, belly buttons. I don't care. So if I add 2 belly buttons over here, that cancels out. If I have 2 belly buttons plus 1 belly button, that gives me 3 belly buttons, which is a pretty weird to think about. So I'll use something else besides belly buttons. So at this point, I'm going to have, like they did here, 3C plus 6 is equal to 15. Now I'm going to go back to what I did before. I'm going to subtract 6 from each side because I'm going to go farthest away from that variable and start just chipping away, getting closer to it. Trying to help, Kelly. So I'm going to, if they're adding 6, I'm going to subtract 6. That goes away. I subtract 6 from this side. That leaves me with 9. Now 3C, they're multiplying there. So that's 3 times C is what that actually is. If they're multiplying, you divide. So divide this side by 3 and this side by 3. 3 is 1, which just leaves me with 1C. I don't have to write 1 in front of it. 9 divided by 3 is 3. So C is equal to 3. And then I go back to my original equation with the C's on each side and see if I can get it to balance. So wherever I see a C, I put a 3 in. Let me try to get all in. Yeah, that looks better. So it's 3 plus 6 is equal to 15 minus 2 times 3. Now, once again, we go back to our order of operations. I have to do this multiplication first. So -2 times 3 is going to be -6. All right. And they went ahead and did this on this side, which you can do. 3 plus 6 is 9. So I'm left with 9 is equal to 15 minus 6. 9 is indeed equal to 9. We've proved it. We know how it works. All right. So we're running up on about 15 minutes left. Let's pause for a minute. Let's everybody soak this in. Have I confused anybody point where they're ready to, have a fit? The good part is we are recording this. You can go back and stop it and look at it at any time in freeze frame. So plus you can go to YouTube, plus you can ask questions of me through the web page, plus you can email me, and you can always, and if I'm not doing it for you, you can try Bob as well. All right, so that's, I'm going to try to get to the actual math as we have here. All right. Here's one right here. Now, 6 times the sum of x and 40 equals to 330. Now, this is what equation looks like when they say it like that, because they're saying 6 times the sum of x and 40. So sum, as we know, means addition, right? And they put this outside those parentheses. Okay. Now, in order to solve something like that, which you may have to, there's a thing called the distributive property. Now, I don't think they solve it here, but let's just look at it, see if they have one that you may be able to solve. Oh, that's what we'll do. We'll go to speaker docs. Well, I'm sorry, let me back up. When you see a number out here and then these numbers inside like this, it could be x plus 40, x minus 40, but you have a variable plus or minus inside of here. There's a thing called the distributive property. Okay. And what they mean is you must distribute this 6. To solve this, you'd have to distribute this 6 into everything inside that. So what you would have is you would have to take the 6 times x. Then you would have to take 6 times 40. And I will just bring up a word page here. So let's just kind of look at what they give us here. They give us 6, x plus 40 is equal to, what is it, 330? So if we want to solve this, I've got to take this and multiply 6 times x and then 6 times 40. So 6 times x is going to be 6x plus 6 times 40 is 240. That's why they call it distributive property. And that is going to be equal to 330. Okay. So just remember, the rule is when you see this, multiply this times this, and then this times this. All right. Then we go back. This looks just like our regular problems, right? We want what we've done before. We want to get x by itself on one side. Let's subtract this 240 out. So if I subtract 240 out, That leaves me with 6x. So if I subtract 240 from 240, that becomes 0. It goes away. I subtract 240 from here. That becomes, was it 90? 330 minus 240 is 90. They're multiplying, so we divide. I divide both sides by 6. Right? So 6x divided by 6 leaves you with just x. 90 divided by 6 leaves you with 15. Equal to 15. Now, in order to check that, I go back to my original equation, which I just copied right here. And wherever I see an x, I put in a 15. Now, this column. Now we go back to our, which is up here, our PEMDAS, right? First thing is what's inside the parentheses. So 15 plus 40 is 55. So that becomes 6 times 55 is equal to 330. And hopefully I don't look like a moron and say 6 times 55 is equal to 330. Hey, I did a thing. So 330 is indeed equal to 330. It's true. We did it right. If you get anything else, if you would have got 195 is equal to 330, we know that's not a true statement. And that's going to clue you off. You're going to go, crap, I did something wrong. And we got to start over and figure out where we went wrong. And that brings us to this one right here. This one is going to cause you some stress. We are given that the total amount of sales for higher price, and they almost like make this huge jump here on you. You go from these problems to bam, here's a story problem that's going to kick your butt. And this will probably take us to the very end of class. And there's a couple of them very similar. One of them has to do with gasoline, and you're really going to have to use your brain. That's fine if you get stuck, hit the Ask the Teacher button. Now, an online store sells 2 types of speaker docks for smartphones. The higher price speaker dock sells for $190. The lower price speaker dock sells for $80. Last week, the store sold 3 times as many lower price speaker docks as higher price speaker docks. Combined sales totaled 3,870. How many of the lower price speaker docks did it sell? That sounds like a terrible thing, doesn't it? So let's look at their explanation, and I'll explain it as we go through. And remember, when you go back through this, you can always pause it. Okay, so we are given that the total amount of sales for higher price and lower price speaker docks are 3,870. So we combine all the sales for those two things, 3,870. We are to find the number of lower price speaker docks that were sold, the question that was asked. Okay. That one of the other things I always tell people too, make sure you understand what they're asking. Don't be like my 11-year-old grandson who is always answering a question that was never asked. Oh, if anybody has kids, you already know. The store sold 3 times as many lower speaker docks as higher price speaker docks, letting E represent the number of high price speaker docks sold. The number of lower price speaker docks is as follows. Okay. So if N is the higher price ones, then 3 times N are the amount of lower price ones you sold, right? Does that make sense? Because they give you the information up here. 3 times as many lower price speaker docks as higher price speaker docks. So they just picked a letter out of the alphabet to represent N being the higher price speaker docks that means, and that's the number. That's, I guess that's why they used N. The number of higher price speaker docks they sold was N, which means the number of lower price speaker docks is 3 times N. And what now you're going to have to add in the pricing. So the higher price speaker docks went for $190. So let's just kind of skip down here. $190 times the number of higher price speaker docks plus $80 a piece times the number of lower speaker docks. Higher price speaker docks, the number of lower price speaker docks. And when you add all that together, you equal to the total amount of sales. Well, 80 times 3N becomes 240N, and you really don't even need those parentheses there. You need them here to differentiate what you're doing, but once you get here, that's 240N. You don't even need it. 190 times N is 190N, just like that. We still have this on this side. We're just going to leave it. If I have 240 N's and 190 N's, I add them together, I get 430 N's. Once again, that parentheses is just kind of redundant, guys. We could live without it. And that is equal to 3,870. Gotta wet my whistle here. Now, this is just like what we did before. They're multiplying, so we're going to divide. I'm going to divide 430N divided by 430. That's just going to become 1N because 430 divided by 430 is 1, right? And I don't know if I've said this before. Anything divided by itself is always 1. Always, always, always. You divide anything by itself is always 1. And that goes for variables too. Okay, if I was to take X divided by X, it would still be 1, right? N divided by N be 1. 240 divided by 240, or sorry, 430 divided by 430 is 1. But if I divide it on this side, I have the other side to do the same way as well. So we know that they sold 9 of the higher price speaker docks. And if they sold 3 times that many in the lower ones, they sold 27 of the lower priced ones. Now, I know somebody has a question on this one, so speak up. We've got 4 minutes left. Well, I'll stay as long as you need me to. I know somebody has a question. Like Corey Taylor Slipknot, spit it out. And Slipknot fans? Probably not. Too young. Too tame. Kelly, you gotta stop. You're not allowed to break me on a Monday night. I have a question. Well, the good part is tomorrow morning, I will put this up on for you guys to look at. What I'm going to do is I'm going to pull, okay, I'm going to start here at the question. And I'm going to pause. That way you can pause the video and look at it. And then I'm going to slide down to the explanation and pause. That's good, Andrew. And then one more slide down and pause. Now, notice something. One last thing you need to notice. Underneath here, it says watch it.
A candy store at the mall sells dewdrops for $4 per pound and gummy flies for $7 per pound. If they sell twice as many pounds of gummy flies as
We'll listen to
dewdrops
2 minutes.
and take in $522, how many pounds of gummy flies did they sell? Well, again, let's analyze the problem. We can come up with this reasoning. We know that the sum of the price multiplied by the number of pounds of each type of candy is equal to the total sales. Let's let x equal the number of pounds of dewdrops, and let's let 2x equal the pounds of gummy flies.
And notice they just pulled a variable out of their ears. We don't care. It's X's, it's N's, it's Q's. I mean, later on in math, you may care because those things mean something, but at this point, for us,
Then let's write our equation. We know that the dewdrops sold for $4 per pound. There were X of them sold. So 4 times X would give us the total value of the dewdrops sold. Likewise, the gummy flies sold for $7 a pound. We said that 2x would represent the number of pounds of gummy flies sold. So 7 times 2x would be the value of the gummy flies sold. That total would equal 522. So we have the equation 4x plus 7 times 2x is equal to 522. Solving the equation, well, we can multiply 7 times 2x to get 14x. Now we can add 4x to 14x to get 18x. Our equation now is 18x is equal to 522. Dividing both sides by 18, we have 522 divided by 18. That's x equals 29. 2x then would be equal to 58. In this particular case, we asked for the number of gummy flies, and since that was represented by 2x, the store sold 58 pounds of gummy flies.
all right. Once you do it once, it won't be that bad. It's just getting it that first time. All right. Well, that brought us to 9:01. I'm going to stop recording and officially stop my sharing, stop recording officially in class, but I will stick around for whatever anybody needs. So I'm going to stop recording.